Hello everyone, welcome back to the Funway Coding channel. Today we'll be discussing about CPU performance and embedded systems. Let's dive in. First let's talk about the factors affecting CPU performance. First is clock speed, second is number of cores, and third is cache memory. So first, clock speed, and we know that clock speed is measured in hertz. And what a clock speed is that for every tick of a clock, which is the internal clock of the computer, for every tick of the internal clock, it denotes one FDE cycle executed. So there are more ticks in a second, there'll be more FDE cycles executed per second. So more instructions are executed per second. So if a computer was to, if you were to increase a computer's performance, you would increase the clock speed so that more instructions are executed per second. Next, we have the number of cores. So the key word is simultaneous execution, because the more cores you have means more instructions are being executed at the same time. Suppose you have an 8 core, so the octa-core on your computer. That means 8 instructions. So 8 different 8 different instructions or FD cycles are being executed at the same time, which improves the performance of the computer. And next is cache memory. Cache memory is bigger than the registers but smaller than RAM. So it has it stores recently executed instructions, so that when you want to go back and execute those recently executed instructions, it is quicker because it's closer to the CPU. So if you want to improve your CPU performance, you can increase cache memory. However, it is extremely expensive. So you may want to increase the clock speed instead. And next is embedded systems. So the textbook definition that we need to know is an embedded system is a computer system built into another device to perform a specific task. And in GCSE, we may need to identify the different features of an embedded system. That is specific task. It has a specific function, only can do a single function. Reliable and long lasting, as it only has few processors. It has a microprocessor. It does not have a RAM. It has a small RAM, a small ROM, and that's it, nothing more. It is hard to change or upgrade because it has already been sent out, so you cannot recall and then change it. Its firmware cannot be updated, and it cannot run general software because it is only for specific tasks, not a generalized computer. So let's say we have a camera, or we can have a radio or a washing machine. For washing machine, if we take an example, then we set the settings of the washing machine. We click the button. Now that button will be over the UI interface. Let's say we have a smart washing machine. The UI interface. You click the buttons and then you press start. And then when you press start, you have given this is the embedded system, as you have given the washing machine a specific task to clean your clothes, or a dishwasher to clean your plates. And at what setting is the specific tasks. However, the washing machine will not be able to play Spotify or play Apple movie or anything you want. It cannot do that because it can only run specific tasks, and that is the keyword: specific task, reliable and long lasting, and hard to change, like hard to upgrade the software. So next time we will discuss about primary storage, the different types, so RAM and ROM, and more into so what is RAM, what is ROM, and then virtual memory, what is virtual memory and why it is needed on a computer. So bye. See you next time.